Brian here with DIY Outdoor Life. Today we're going to talk about installing 12-volt outlets on our camper. After the last video we did where I showed how to backfeed your camper through a portable power station, I'll tag that up above. A lot of people reached out and wanted to know how to install various types of outlets. They also want to know how to splice into an existing device and how to tie directly into our converter or a fuse block on our camper. So we're going to go over all these methods, and in my description I'll give a list of the products I use to try to make this easier for some of the people trying to tackle this project. So for starters, we want to make sure that we're getting the right style of plug. They make these automotive or cigarette style plugs in a couple different styles. Some of them have face plates, so we can drill a hole, draw the wires through, make the connection, slide the plug in, and screw it from the outside. This is the style that we'll use if we don't have access behind the wall. They'll also make a panel style plug. These are great if you want them to fit into a pre-existing panel. This is the style we'll use. But also, with the threaded nut on the back, if you have access behind, like a cabinet or maybe someplace in your galley, you can drill a smaller hole, draw them through, and you reach back to thread the plastic nut from behind. This makes for a nice, clean, secure job, but it does require that you have access behind. So we want to make sure that we're getting the right style. This one that I've been using and the one I stock is a marine grade plug that is both. It has the threads on the back because it comes with this little faceplate. So some of them are fixed. This one could actually be used either way. So I'll link these in the description so you know the right type to get for the job you want to do. These 4-in-1 panels are really nice, and a lot of people want one of these in their camper. It is considerably more difficult to install these. We'll go over the basics of how to install one of these as well, but for today I'm going to be using this as the existing power source in the camper. So this could be a radio, it could be a USB block, or anything that's supplied by 12 volts that goes back to the fuse block on our camper. So we're going to splice into this device today to be able to install one of the two different types of outlets. And then at the end, I'll show you how to tie into the load center if you want to go that route. So the first step is going to be to remove the device that we're going to splice into. So I'd take the screws out of this device, remove it from the wall, and we're going to draw the wires out. You might find an inline fuse, but we're going to carefully draw these out until we get to this. Right here, you're going to see the splice from our device that goes back to the fuse block. It's usually going to have one or two of these types of small compression nuts holding it together. Now chances are your 12-volt device came with two little pigtails. There's going to be a female spade connector on one side. That's what will plug into this. The other side will either be stripped or require that you strip those wires. Occasionally, they come with a little eyelet on the end that we would just snip off. That's for going directly to a battery. But with this end stripped and preserving this end for this outlet, we're going to merge the new split end with the wires that are coming from the wall. Now I don't tap in down here. I'm going to tap in right here at these wire nuts. Your red or colored wire is going to be your 12-volt supply, and your pathway to ground is either going to be black, white, sometimes it's green, but the vast majority of the time you'll find it on DC systems to be black or white. To remove these little compression nuts, you can squeeze them with pliers, and most of the time they slide right off. If they're giving you trouble, just snip them and re-strip the wires. Just make sure our supply lines don't drop back into the wall. Sometimes people wrap a piece of tape around them. If they fall back in, you're going to be fishing them out with a coat hanger. As we splice the three new wires together, there's a couple different ways to do this. Again, we're splicing the new pigtail for the 12-volt device from the supply side as well as the return side. There's going to be two three-way splices here. I want you to twist these together really, really well. You could do this by hand, especially if you're wearing gloves. When you twist these together, it should be secure before the wire nut. Now in the description, I'll include a little multi-pack of these compression style nuts that they use on campers. They work better than twist-on because this is a high vibration environment. I'm also going to show you how to use a WAGO connector. These things can take beginners and turn them into experts. If we're using a compression style, we'll twist these up really good, trim them off, install a new compression nut, and then crimp it on. I'll do this for the black side as well as the red side, and then we're able to move on. Right now, let me show you real quick how to use those WAGO connectors. This device here is designed to make a really easy to use, serviceable splice. You can get these in a variety of shapes and sizes, and I'll try to include a multi-pack in the description. You just lift the lever up, slide a stripped wire in, close the lever, and you have a secure connection. If you want to come back and work on it later, it's as simple as lifting the lever up and you can remove the wire. They accept a variety of wire sizes, and you can even mix and match different gauge wires. It couldn't be easier. So now, whether I use the crimp-on wire nuts or the WAGO connections to make the splice, I'm ready to tuck these back into the wall. I can now take the two new leads that I'm using with the spade connectors on the end, and I'm ready to run them to the new spot that I'm going to use for a 12-volt outlet. But first we have to drill a hole. Now, the hole that we're drilling has to be pretty accurate. If you're using these panel style plugs, most of the time it's 1.125 hole, and it makes a nice clean installation. If you are using one of the panel style plugs, it might be 1.125, it might be 1.25 inches, or if you're using this marine style plug, you have to clear the nut that's on the back. That's going to make it 1.5 inch hole in order to slide through, clear that nut, and the face plate covers. So once I drill that hole, most of the time I can just poke the wires through, by reaching my hand in. If you have to snake them through with a coat hanger or something, that's fine too. For today, I'm going to cheat, and I'm just going to reach in the back and slide these wires out. I'm going to pull it right through so my little inline fuse comes out. And now I'm ready to reinstall the original appliance. So I put it back through the hole, set my screws in, and now I'm ready for the final step. For this final step, I just have to firmly push these two female spade connectors onto the back of the outlet. Our red or hot wire goes to the positive side, and our black or white wire, or negative ground wire, goes to the negative side. I pull the wires back into the wall, I push them through the front. I set my screws, and now my new outlet is installed. I'm going to show you one little trick if you're using one of these 4-in-1 devices, and then we're going to move on to tying directly into the load center. So these little 4-in-1 panels get wired exactly the same way. They'll come with directions because they have these little pigtails to link everything together on the back, and they usually start with a switch that can shut the device off. So that section is going to have 3 spades that need to be connected. Now you need to read the directions for your exact device, but most of the time the 12-volt supply goes to the middle spade of the switch. That's how you supply it. The switch then can turn off the other devices. What makes these so difficult to install is they typically give you very little room to be able to cut your hole and still catch this screw hole to be able to fasten it. So you can't just cut a square hole to do this. If you have access behind, you're going to be drilling 4 neatly placed 1.125 holes by using the template to position those. From there, you would slide the device in, screw the 4 nuts from behind, and wire it from behind the application. When you're installing it to the inside of your cabin, you have to drill 4 very neatly placed 1.5 inch holes. When those are in order, you can cut the center piece out. Now I just roughed this into the piece of plywood, but you can see that it barely goes in, so that when it snaps in place, you still have room to drill the 4 holes in. I've seen a lot of people, and I've even made a few mistakes installing these, and then you got to use like a new panel of wood or something to try to fix that. So take your time with this, practice on a scrap piece of plywood, make yourself a template, and you'll be able to get these done. Wiring them is easy, and once you have them, it's really great to have inside your cabin. But now let's get to the load center. So it's still difficult to film inside the camper with all the power off, so I'm still going to demonstrate out here on the board. I'll crop in some photos and videos to try to illustrate what we're talking about, but this job is going to be easy. It's just like the splicing job, but instead of using a pre-existing appliance, we're going to go right back to the source here. So the first thing I want you to do is open up the door on the converter and look at the different DC circuits that you have. There's going to be fuses next to them. We're looking for one that's either not utilized or using a 15 amp fuse. Most of the time we're going to find that most of them are using the 15 amp fuses. A 30 or a 25, these things are reverse polarity or they're the battery charger. Most of our appliances will be set for 15 amps. So I look for one that's underutilized, maybe one that goes to the fan or lights, and I skip over something like the refrigerator. Really, there's enough space to use any of these that you want. But once you've selected one, let's say it's number 3, we're just going to remember that we're using circuit 3 as we take the next steps. I remove the cover plate, and then I unscrew the 4 screws and draw the whole converter out from the wall. The fuse block, the charger, converter, the AC load center, all this stuff is combined in one box. As you pull it out from the wall, you're going to have to reach back and slowly help draw all of the bundles of wires out. If your electrician did a good job, this is a really neat project to do. But seeing that seldom times do I find good work back there, it's probably going to be a bird's nest worth of wires. Just take your time drawing them out. Now, your DC feeds, it's only going to be the positives, are coming out of the bottom of that panel. There's going to be as many wires as there are DC circuits there. They'll either be numbered and correspond with which fuse they go to, or they'll be colored, and on the back of the fuse panel, it'll tell you which color goes to which circuit. So we'll just check out which color is for circuit 3 and just kind of comb through those wires until we find that circuit. You're going to see that it's going to have a plastic wire nut on it, just like what we were doing before. And we're going to repeat the same step, either snip it and strip it, or you can squeeze and maybe the wire nut will come off. But now we're going to create a 3-way splice for that circuit. In this case, I'm just using imaginary number 3. We've selected the circuit. Let's say it's red. So when we do that, we're going to require new wire here. I don't want to reuse the little wiring that came with the 12-volt outlet. So I'm going to get a piece of 14 gauge stranded wire, nothing solid. Since I have 12 gauge, it's easy to work with, and I'm going to do that. It's even overkill. When you see factory jobs, they usually use 18 and 16 gauge wire. At this length, that's perfectly acceptable. But if we're doing it ourselves, we might as well do it overkill. So in this case, I'm going to be using a 12 gauge wire. Now, once you've created that 3-way splice there, you can use the WAGO connectors, or you can use these little crimp-on connectors that we're doing. You could put a band of tape around it. Do a good clean job here. But if you're using those WAGO connectors, you can come back and service it later too, which is really nice. The next thing we're going to do is get a piece of white wire. So if I'll include a link in the description that includes both colors. You can use white, you can use black here, but we're going to use this for the ground. Now the ground does not go into the panel. There's going to be a little bus bar. There's going to be a little section screwed into the cavity where the load center used to be, where your converter used to be installed. You're just going to take that end of the wire that you stripped, twist it really good, and slide it into that bus bar and tighten it down. It's okay to share a slot with other wires. It's going to be really easy to identify. It's the little section where all of the white, black, green, and bare wires go to. It sends a pathway down to your frame and goes all the way back to the negative of your battery. But once we've screwed into that negative bus bar, that grounding bar, and we've come to, I lost my wire, and we've installed a WAGO connector or a wire nut to put a three-way splice here, we're 90% of the way through this project. So now that I have a splice coming off a 12-volt circuit and a pathway to ground, I can drill the hole that I'm going to use for the 12-volt appliance. I prefer using that marine style plug that takes 1.5 inch opening. I'll try to list that in the description so you can see the one I'm talking about. This bigger hole is going to come in handy here. Now, I'm going to go to the left of the converter. I know there's going to be a stud here, but with the converter removed, I can stick my drill in and drill a hole through the stud. It's very easy. If you're looking for an even easier option, just go below the converter. You can reach your hand down there, pull the wires away, and make a simple hole there. Just be careful when you do it. Now I'm going to cheat and just stick the wires through the hole. But you get the idea. You're going to have to take your time. You have more space to work with here and fish the wires through. From here, I'm going to install a female spade connector on the negative. I've included this kit in the description before. I'll do it again. It's a real cheap assortment of all of these connectors, but that female spade connector is what goes to the outlet that we're using. We're going to pick the right color to correlate with the wire gauge that we're using. This stuff is pretty straightforward. That's why I'm moving quickly here. On the positive side, I like to install a blade style fuse. It's the same fuses that we use in the converter, which makes it very simple. If you're going with the smaller hole option, the blade is not going to fit through. You're going to have to go back to using one of these inline fuses. That's why I prefer the marine plug here. The hole is big enough for this fuse to come through. Now folks, they'll include these little fuse holders for 15 amp fuses, typically with like 16 gauge wire, sometimes 18 gauge wire. It's very short, so don't worry that you're derating your circuit here. This is perfectly capable at this length to carry the same current as the heavier wire for a longer length. If you want to trim it a little shorter, that's fine, but because it's a different gauge, you might have trouble with a butt connector here. So it's going to be a good idea to go back to your compression style fittings or use another WAGO connector. Once this is connected with a female spade on the end, we're going to be able to plug right into our new appliance and we're all done. This project takes longer to explain than it does to install. So with the crimp connector on the positive here going to that fuse, I tuck all my wires back through the wall. Make sure you install that 15 amp fuse into this connector. It's not going to work if you forget that, but that'll slip right through the hole. Tuck your wires back in. Make sure your plug is level, screw it in, you're ready to go. You can return your load center if you haven't already, but now you have a high performance option here. Because of the larger wires, the better fuse, and the shorter distance, you will have higher performance when you're running a plug-in inverter to run outlets for a TV or something small. If you're doing that backfeed, you're going to get higher performance. There's going to be less voltage drop, and you're going to be able to carry higher currents. So this style, close up here, is a higher performance option. Guys, I threw this video together based on people's emails and questions on Facebook. I hope it helps. Make sure to check out my other videos and leave a comment if you have a question. All right, I'll see you guys next time. Thanks a lot.